going to use our unit circle to solve questions we used to do in grade 11 with our calculator. Now we can do them without our calculator. Well, these usually involve solving, they can be in radians or degrees. How do you tell if a question is in radians? Usually there is a domain given to you. So the fact that this question says that the angle theta is somewhere between 0 and 2 pi, that's telling you to think in radians, and it's saying we're going to go once around your unit circle from 0 to 2 pi and see how many answers we get. And what we're looking for is, in a question like this, is your y-coordinate ever root 3 over 2? Again, you'll often have your first quadrant memorized, and if you know one of them really, really well, like if you know that sine of pi over 6 is a half, well then theta can't be part of your pi over 6 family because this is root 3 over 2. That might help you realize that the family here is your pi over 3 family. And sure enough, if you look in quadrant 1 to your pi over 3 family, your y-coordinate is root 3 over 2. But then actually solving for theta, sine of theta is negative. According to our CAST rule, that means you're going to be looking in quadrants 3 and quadrants 4, because sine is negative in quadrant 3 and 4. What is your family member for pi over 3 in quadrant 3? 4 pi over 3. And remember the strategy for remembering family members in quadrant 3, that the denominator is always just one more than, the numerator is one more than your denominator. Okay? And then in quadrant 4, 5 pi over 3. Because your numerator is always, if you double, minus 1. 5 pi over 3. And the question is done. Here's your final answer. Without a calculator, using your pi plate, you're able to get that really, really quick. Okay? On a test, probably you wouldn't show any of that other, like, did I really need to rewrite the question? No. Right? I wrote it down again. Sometimes there's something therapeutic about rewriting a question down. Not necessarily. Reference angle, for sure you could have that in your head. You wouldn't have to write that down. You could just write the answers down on a question like this and be totally fine. So again, maybe what I'll do is, in the green box off to the side, I'll write down some of my thinking. Actually showing that work on a test or a quiz or an exam would be optional. Okay? Cos theta equals negative 1. In my thinking, I would think axis family. Because zeros and negative 1s are all on your axis family. In my thinking, I would say, I know from the big idea that cos is my x-coordinate. On my axis family, is my x-coordinate ever negative 1? Yes, right here. So the answer to this, that's all I'd have to show, is theta is equal to pi. I put the thinking off to my side to show you how I get to that answer, but all I have to write down is pi. That's the only place that my x-coordinate is minus 1.
So because it's negative, that's why you went the other way.
Because it's negative 1, I'm actually looking for that coordinate to be negative 1. Right? So on my unit circle, right here, my x value would be negative, my y value would be 1. And cos is my x-coordinate, so it has to be pi. Okay? Again, the domain is from 0 to 2 pi. The textbook likes to switch your domain up. Sometimes they'll say negative 2 pi to 0. Sometimes they'll go negative 2 pi to 2 pi. And eventually they'll say, yeah, everywhere. So you have to write every single coterminal angle that exists. right? But we did coterminal angles already. Remember when we did the angle plus in degrees, 360 degrees times k? In radians, you would do the angle plus 2 pi times k, because once around the circle is 2 pi. So we'll get to that. That coterminal idea is going to be coming back for us again. Okay? Here's my thinking box. I see tan theta equals -1. I know that my pi over 4 family gives me tan theta equals 1. So I know it's going to be part of my pi over 4 family. I know from my cast rule that since tan is negative, I'm looking here and here. With that thinking, I can write the answer down. I know that it's going to be in quadrant 2. There's my pi over 4 family member in quadrant 2. I know it's going to be in quadrant 4. There's my pi over 4 family member in quadrant 4. And again, all you would have to show on a question on the test is the blue. Just have to write down your answers. It's expected to be mental math that easy. But what you have to think about is what family is it? And what quadrants is it in? If I have secant theta equals 2, even though this is part of my thinking, this would be something I would expect you to write down. So I'll write it in the blue part, not in the green thinking box. If secant theta is 2, go to your primary trig function, because you know sine, you know cosine, and you know tangent much better than you know secant, cosecant, and cotangent. So if secant theta is 2, then cos of theta would be the reciprocal. Again, the angle's not changing. The ratio is the reciprocal. And from that, I would be like, in my thinking box, I'd be like, oh, that's definitely my pi over 3 family. I'm definitely looking where cos is positive. That's in quadrants 1 and quadrants 4. So based on that, I can write down the answer. What is your pi over 3 family member in quadrant 1? It's pi over 3. What is my pi over 3 family member in quadrant 4? It is 5 pi over 3. Good? Or is it hurting the brain a little bit? Okay? As far as showing work, I would definitely move the 1 over, divide by 2, and get sine theta by itself. And that 1/2, this is why I say it's really, if you memorize 1 really well, pi over 6, sine of pi over 6 is 1/2. So now I know my reference angle. And according to my cast rule, sine is negative. I know it's in quadrant 3 and quadrant 4. So now I can just say, what's my pi over 6 in quadrant 3? 7 pi over 6. What's my pi over 6 in quadrant 4? 11 pi over 6. And there's my final answer. Question? Actually, And now we go on to the next level. Yes, question. Yeah. Yeah. The second quadrant's always one less than this. So the pi over 6, if I wanted to find my pi over 6 family member in quadrant 2, it's 1 less. And that whole idea, if you want to think about that whole idea for quadrants 2 and quadrant 3, is all based on a reference angle. So if my reference angle is pi over 6, and I know that halfway around this pi, this angle in green would have to be pi minus pi over 6. But how do we subtract fractions? We need a common denominator, so I change my pi to 6 pi over 6 minus 1 pi over 6. And since my reference angle is always one of them, does it make sense that the number on the top will be 1 less, because you go 6 pi minus 1 pi, give you 5 pi. Here in quadrant 3, you would have 6 pi over 6, which is pi, and then you'd add your reference angle. And since your reference angle is one of them, it makes sense that you get one more in quadrant 3. And when you get to quadrant 4, the reason it's double minus 1 is because in quadrant 4, I'll draw it in purple, there's my reference angle of pi over 6, all the way around, which is 2 pi, is the same as 12 pi over 6, doubling the bottom to make 2 pi. And then you're subtracting one of them. So the idea is based on fractions and how do we find things using our reference angle. But then the pattern that comes up is they're like, oh, it makes sense that it's always 1 less in quadrant 2 in your numerator, 1 more in your numerator in quadrant 3, and double minus 1 in quadrant 4. All right, so now we move on to connecting quadratic stuff from grade 11 to solving trig equations in grade 12 with our unit circle. Okay? So first of all, remember quadratic functions where you have something squared. And here's the little reminder for solving quadratics. Your teachers probably said this a ton in grade 11. So in grade 11, they would have said, first of all, you need to make one side 0. Then you either had to factor or use the quadratic formula. But it's very important that one side is equal to 0 first before you do either of those. So in our question here, one side's equal to 0. Can we factor cos squared theta minus cos theta? What is different here is you probably haven't done a lot of factoring where there's trig functions. But you really have to think, this is the same idea as just something squared minus something equals 0. Because I have cos squared theta minus cos theta equals 0. That's like x squared minus x equals 0. Do you remember how you factored this? You factored this with a common factor. There's an x in both of them. There's an x in common. So in grade 11, you would have taken out the x, leaving you with x minus 1 equals 0. And also a little reminder of why factoring is so powerful in solving quadratic equations. Because you changed an equation which was subtracting to equal 0 to an equation this gives me shivers every single time, that's multiplying to equal 0. I will show you the power of this with an easy example. In my head, I have two numbers. I subtracted them. I got 0. Can you tell me what one of the numbers has to be? If I subtracted. No, one wasn't 0. Try again. Guess again. I've got actual numbers in my head. I subtracted them. I got 0. Can you guess what I have in my head? No, it wasn't 1 minus 1. It wasn't 2 minus 2. It's good guesses. How long do you think it's going to take you to guess before you would have figured out that I picked 3.3? Oh, I was like, it'll take. You would have been pissed off trying a whole bunch of notice how everybody picks whole numbers first? You'd be like, no, you got 3.3 minus 3.3. Come on, Mr. PR, that's not very nice. But as soon as we change it to multiplying, this is why it gives me shivers. As soon as you change something to multiplying, and it's equal to 0, I'm going to put two numbers in my head. I'm going to multiply them. The answer is 0. You just have to tell me one of the numbers. 0. One of the numbers has to be 0. This is why this is so powerful. Either this number is 0, and if this number is 0, you'd be like, oh, x would be 0 if that number is 0. Or this number is 0. And if this number is 0, well then what would x have to be? 1. And it works. Okay? You would have never, the other number was 7.9. I don't think you would have got the other number. But the 1 has to be 0. So if we factor, that's why it's so powerful. Now with cos, we would say, hey, I can take out a common factor of cos. This leaves me with cos of theta minus 1. And I just changed it right here to multiplying, which allows me to use that powerful 0 property. I know that either this one is 0, so either this cos theta has to equal 0, or this one has to equal 0. And if cos theta minus 1 is equal to 0, then cos theta would have to equal 1. And now it becomes a pi plate question. These are both axes families. Cos is your x-coordinate. Where is your x-coordinate? 0. At the top here and at the bottom. So this answer would be at pi over 2 and 3 pi over 2. Cos theta equal to 1. Yes, axes family, that's right over here. That happens at 0. It also happens at 2 pi. And I have to include both because I have equal signs in my domain. 0 was included, 2 pi was included. I have to write them both. You know what your textbook likes to do? They like to sometimes write one of them is included and one of them isn't. And then if you did the same question and wrote 2 pi, I'd have to take off a half a mark because you gave an answer that wasn't allowed. Textbooks mean that. So we really have to be careful with the domain when we're solving these. What do you think? Do we have time for one more? Maybe? Oh, I didn't. What about pi? But at pi, cos theta is minus 1. So we can't include pi in this situation. Okay, if you had just something squared with regular numbers, what would you do? Right? You'd probably move the 4 over and square root both sides, right? What would I write for x? Plus or minus 2, right? You have to remember that plus minus. So I'm going to do the same thing here. I'm going to write sine squared theta. I'm going to move the 3/4 over. I'm going to square root both sides. Remember the plus or minus. Now, if this is a non-calculator question, we have to remember how to work with square roots. A square root of fraction is the same as the square root of the top divided by the square root of the bottom, and the square root of the bottom is just 2. And then we recognize root 3 over 2 is part of our pi over 3 family. And according to our CAS rule, we need positive or negative. That means the whole family is invited. Every single quadrant. So we would have quadrant 1, pi over 3, quadrant 2, 2 pi over 3, quadrant 3, 4 pi over 3, and quadrant 4. 4 answers to this question.